Hello everyone, welcome to this session on synthesis and Verilog coding. So here in this session we are going to discuss about the labs on partial if condition, what are the inferred latches, what are the dangers of using incomplete if, incomplete cases and partial assignment in cases, all those things, all these concepts we discussed as a theoretical concepts in the previous session. We are going to see that practically in action now, how the simulator and the synthesis tool behaves when we have all these incomplete if or incomplete case constructs. Okay, so let's get started. So all the files we are going to use are in this folder Verilog files. So first we will look at all that incomp files. I'm going to list them. So we'll start with incomplete if. Okay, so first let me open all the files. So all the files are going to open. So we'll quickly see what are the first. We will start with incomplete if. Yes, it's here. Incomplete if. Let's look at this code. For every code we are picking, we will look at the RTL as well as what happens when we what will happen when we simulate the RTL, what will happen when we synthesize the RTL. Okay, so this is the RTL. We have an incomplete if. So what's happening? Input we have I0, I1 and I2. Output is a register. Output is a reg variable called y. Always at star. If I0, y gets I1. So let's look at how the look. So I have if always translates into a mux. So if always translates into a mux, I have a mux whose select line is I0. If I0 is high, then I'm going to connect the output to I1. Else, now the question is for the else. Else what is going to happen? Nothing is mentioned, so y will latch on. So this is nothing but, if you see the behavior here, this is nothing but a delatch, correct? This is a delatch which latch enable as I0. It's a pause latch, correct? Whenever I0 is present, I1 is seen on Y. Whenever I0 is absent, it latches onto its value. If I0 goes low, Y simply latches on. This is what is the behavior we are expecting, correct? There is nothing but this, correct? So let's see what we are getting. This is what is our analysis. Let's see what happens when we simulate it and what happens when we synthesize it. So as usual, we will use iVerilog for simulation and use this for synthesis. So iVerilog, we saw incomplete underscore if, tb underscore incomplete underscore if dot v dot slash a dot out. This generates the incomp if dot vcd. Let me open this. So we have I0, I1, I2 is not used at all in the code, so we will not be bothered about it. So let's see here what happens. Bingo. See, clearly we are seeing this, correct? Whenever I0 is going low, I0 is going low, the output Y is latching on to something. It's either 1 or 0 permanently, correct? There is no change. There is no change in Y whenever I0 is low. If you see here, I0 is low here. There's no change, absolutely no change in. So this is clearly the latching action, correct? It's exactly like a latch. Whenever this signal is high, I'm getting the, I'm seeing that Y is following I1. Whenever this is high, Y is following I1. Whenever this is high, this is my I1, correct? So let me put it in different color if you want. So see this, whenever select is high, whenever my I0 is my select line, correct? Whenever I0 is high, at that time my Y is exactly following I1. Whenever I0 is going low, at that time there is no activity on Y. It's constant either at 1 or 0. I don't know whether it's 1 or 0, but whatever value it takes, it's constant. Now what value it is taking, let us see. Now this is the instant at which I0 is going low here. Now if you see, just before I0 went low, I1 was 1. So the moment I0 goes low, it is latching on to that value. Here similarly, when I0 is going low, the value on I1 is 0. So Y is latching on to that value. This is what is happening with the incomplete if, because it's an incomplete if. Correct? This is exactly following the behavior as what we expected here. Correct? So now let us go back to our synthesis and see what happens in case of synthesis. So uses is our tool. I have kept the uses ready here. So we do read verilog incomplete if dot v, and we are going to set this as the synth-top. I'm not going to read the liberty files because I have already read and kept. So synth-top incomplete if. See, clearly there's a D latch inferred. We coded mux, correct? Our aim was to code a mux, correct? Our aim was to code the mux, but you see here, our aim was to code the mux, but what we got is a latch. Clearly, the tool is inferring a latch. Let's do our ABC and complete the synthesis and see what happens. It's exactly inferring the latch. This is what we expected, correct? I2 is not used at all. I0 is the enable pin. D is connected to I1. Q is connected to Y. This is exactly what we expected, and this is exactly what we are seeing here. It's a D latch with I0 as enable. This is exactly, synthesis is referring a latch, and simulation is also inferring a latch. This is the danger of incomplete if. We don't want a latch, but we will get a latch. This is what is called as an inferred latch coming out of incomplete if. Clear? Now let's go to the next code and see what is present there. So we finished incomplete if. So let me close this. We don't need the VCD file. So let me close all the VCD files. Accidentally they also got opened. We don't need the TB files also. So let's look at incomplete if 2.